Alrighty, this episode we are going to talk about a different way to turn the wheel. This is a theory I have. I'm going to go over it with you guys. I'll bring you into it and through it. Alrighty. So, you see the pipe, it's in the ground. Ed has one identical to it. What I want to do is create a solenoid. This is my adjustable prototype solenoid that I'm just kind of trying to figure it out. Go on YouTube, how to make a solenoid. You get into a couple different things, but we're going to talk about that briefly. But let me just give you an example how I want to turn this wheel, and then we'll get into the solenoid part, okay? So over here on the wheel, we are going to be putting the solenoid over here. So it'll be around this position here when it starts pulling. It'll pull a quarter turn, and then it'll stop. The wheel will come around, come back on itself. It'll come back up, and then from here, it'll start pulling again, and it'll stop about here. So I'm going to do it backwards. I'm going to do it with my hand, and I'm going to pull from that far end, which would be 12 o'clock, 12:01. I'm going to pull about position 3 o'clock, and then I'm going to let the wheel pull. And I'm going to show you how little energy I exert on turning this wheel. I'm just getting it started. It's no easy task. So I'm going to get it rolling a little bit, get it up here. So start pulling, let go. Pulling, let go. Pulling, let go. Pulling, let go. Pull, 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 let go. So you can see the wheel is turning. And really, I'm not putting a lot of energy. I'm riding it 3/4 of the turn. And this wheel is pretty tense, and it'll stop on a dime all the time. And right now, it's keeping momentum going because of the weight of the wheel and because of the centrifugal force that it presents on this weight. So if I just give it a little tug, 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 you can see this wheel way more speed than I can get from using the PMH, which I displayed. I can turn the wheel with the PMH. What I don't like about that is it uses up the magnets. It screws the magnets up. And I thought if I were Ed Leedskalnin, he had every opportunity on experimenting with his wheel, with it turning with the handle. So, now, back to the solenoid. So I wrapped this. This is 5 turns, 66. So that's 6 times 5 is 300 turns plus, okay? A 14 gauge wire. Right now I got 2 car batteries coming out 24 volts. I got a 5/8 slug right there, good 3 foot long, okay. I got the 3/4 inch PVC here, adjustable solenoid I made so I can. Now the way I have this set up right now, this is taking some of the induction out. One is I have more turns than I need, but I'm trying to keep the heat down. And 2 is that we are away from the pipe. But this is experimental. So this is my prototype on trying to figure out what strength do I need to mimic the strength I just put in here. That little strength, once you get it going, I'm not really pulling. I'm putting a lot of strength in it. I'm just putting enough to give it more than the speed of the wheel that's turning, and then that wheel will maintain that speed. So just the timing on this quarter duty cycle is going to require some engineering on my part too. Even the lobes kind of present good too, because a lobe presents a quarter. So if I put a wheel on the lobe and have it connected, then it lets go. That might be the way to go. But it would have to go off on one lobe only. So it's one lobe per cycle. I'll have to figure out how do I not have it go off on the other lobes. Just bringing it up, okay? And what that'll do is that'll free me up. We can have the wheel turning. We can charge these magnets back up. We can see what we get with the coils around them. We can see what we get if we put the coils on the outside of them. The whole thing is experimental, okay? So you got that. Now over here, I got some marks on the pipe. And we'll stick it all the way out here. You can see how much of that pipe is how much is in. So we're going to stick in about a foot. Foot brings us to right about the front of this. I have this all marked out. So let me come over here. I'm one-handed again, guys. And I'm going to have to touch this, and I'll show you this. Wow. Not easy being one-handed here. All right, so we're a little too far out. So we're going to scooch in just to that white line, right? Okay. And we'll step back. Got my Arky here. And ooh, came out the other side. Now, I can't show you guys with my camera set up right now. What I want to show you with, you know, how far back it pulls, and not how far back, but the pressure that it exerts. So I'm experimenting right now. If you guys have any questions or want to add anything, please do. You know, this is all kind of open workshop. I'm thinking that the diameter of the metal matters also, but it'll also matter it'll burn a lot of energy. It won't be efficient because of the iron core being so big. Like if I use, which I'm thinking, I'm going to have to experiment. I got this nice square stock. 2 4-foot sections of the square, 1 inch and a half square, Ed Leedskalnin style. But it'll draw more energy through the coil. If you think about what's really happening is you got this to the battery. The battery's amperage is being based on the wire, the turns, and then also the amount of core that is saturating the field. So the bigger the iron, the more saturation, the more power it's going to take. But I would think that it would be enormous on pull. One thing I want to talk about would be Ed Leedskalnin's magnetic current. In there, when he was talking about how to make a coil stronger, or how to make a magnet stronger, was to encase the coil with iron, steel, and close one side, and the outside casing becomes part of I guess the core. So the outside part of the case, and on one end will be north, the inside core would be south, and vice versa on the other end. So, and he says it's really great for pulling strength. So I just wrapped this with aluminum and didn't notice any difference, which I expected that, but I got to experiment and try it. Tomorrow I'm going to wrap it with some steel pipe, and we're going to check and see if I gain more, because listen, it does make sense. This is radiating outward also, and that's where loss is. I know we have air here, which insulator and insulation, and we're kind of got a good, you know, outside tension on it that's driving it in its direction, but it is going to radiate out, and it does. And I think if we can encapsulate that, we can probably conserve more energy, plus build up more magnetic strength. Another thing I wanted to talk about in my journeys now of my new toy, my new boy toy, my static generator, I'm noticing similarities now with magnetism and static. And so far, I'll share with you guys what I've noticed is that in magnetism, well, we'll start off with static. Say if you had 3 objects, and there's 1, 2, and 3, okay? There's 3 objects. And let's just say they were all the same material. Now, let's say that this one here is charged, okay? And the red end represents a positive charge. So this is a static, positively charged rod, okay? Over here would be another rod, and this is another rod. And this rod's neutral, and this rod's neutral. Now, when we take this static rod and come over near, not touching, just near this other rod, what's going to happen is the electrons, so we have a positive over here. What's going to happen is the positive is going to repel positive in this other rod. So the positive are all going to come down this end. And then up here is going to be the negative end of this rod, okay? Now, what we do now is we bring in a third rod. The third rod now comes in contact. The special thing about this third rod is this third rod we're going to connect to ground. So we're going to take Mr. Ground wire right here. It's a nice Mr. Ground. And we're going to connect the ground wire to this third rod, okay? And what's going to happen now is, remember, the top is positive. It's repelling positive over here. And there's a negative built up on top of here, but nothing's switching. There's no sharing any atomic electrons or protons. It's all just moving, okay? So now on this third rod here, we're going to come to the bottom of here, and this is going to be obviously positively charged. We're going to come up over here, and then on this end of that rod, it's going to absorb. So if there's positive coming out of here, and negative is flying up top here, and positive down here, that positive there is going to repel the positive down here. And what's going to happen is down here, you're connecting to the ground, Mr. Ground wire. And out of the ground, you're going to collect out of the ground electrons. Now, this will happen in one duty cycle, okay, guys? That means that once this is charged, it no longer will pull from the ground, nor will anything else. And the way we'll go over it in another video on how to make this duty cycle that I speak about. Now, we're not sharing electrons from this. We're not sharing electrons from this, but we're causing an effect to where we can pull from ground. I want you guys to leave your comments. I know that's some cool stuff I just wanted to share with you. Back to my turning the wheel Ed Leedskalnin style. I noticed that, back on topic, that the difference between static and magnetism having some similarities is that in that explanation of a sample I showed you guys on stuff that I'm working on with static, that in magnetism, when it comes in regards to this coil over here is a south, over here is a north. So with this being a south end, this metal will always balance itself out and equalize itself in the middle of this coil. And it does it to every solenoid coil you could build out there. And the true question is why? Well, I'll tell you why I think I figured it out, is because the south part, it don't matter if this is north or south, but I'm telling you what I have here is this is south. This south, when this iron comes up close to the south, it's going to repel south. It's going to repel electrons. Well, it's going to repel protons, push them to the far end of the steel. And it's going to be having the electrons up in the front end. And what happens is once these balanced figured space in the iron, which is dead center of electrons and protons, come in the center of the coil, it stops itself. It'll ricochet a little bit and snap back. So it's good things that I'm starting to notice by getting into the static versus just magnetism. But there are similarities, guys. I just want to put it out there for you guys that are just learning about this stuff and all the questions. I appreciate the emails, the comments.